Assalamu alaikum. My name is Gunzar Shahid. I am from Chemistry Department. Today, my topic of presentation is characterization of the conductive smart polymer for the actuator. Objective: aim: synthesizes are the precure conductive polymer film, measure the electrical conductivity, and evaluate the swelling, actuation, response to the stimuli, pH solvents, techniques, 4-point probe, impedance, spectroscopy, optical stain, measurement, SEM, deliverable actuation versus the stimulus plot, lifetime, cycling data, suggestion actuator. Abstract. Conductive and the smart polymer are the emerging as promising material for the soft actuator, artificial muscles, variable motion system, biomedical devices, and the flexible robotic component. Means the conductive and the smart polymers are the special plastic that can conduct electricity, and they are becoming very useful for making soft machines like the artificial muscles, variable devices, and the medical tools and the flexible robots. These polymer possess the unique capability of the coupling electrical and the chemical activity with the mechanical deformations. These polymers can change their shapes or the move and are moved when the electrical or the mechanical signals are applied to them. When pauses are an external stimulus such as the electrical potential, humidity, temperature, ionic temperature or the light, these materials exhibit bending, expansion, construction and the stain-based actuation behavior. Means when things like electricity, moisture, heat, ions are the light effects, these polymers they can bend, stretch, shrink or move. Next, the present assignment focus on the synthesizes are the procurement of the conductive polymer film followed by their systematic characterization using the electrical, mechanical and the structural techniques including the 4-point probe, conductivity testing, impedance spectroscopy, optical stain and the actuation analysis and scanning the electron microscope. This assignment is about making making or getting thin sheets of the conductive polymer and then carefully testing them to study their electrical properties, strength, movement, and the surface structure using the different laboratory techniques. This goal is to correlate the electrical transport behavior when the actuation performance, lifetime stability, and the potential actuator application. Mm, um, the main aim is to understand how the electrical properties of the polymer affect the movement, durability, and the usefulness as the real actuator devices. Next is an introduction and the background. Conductive polymers such as a polyethylene, polypyrrole, PE dot and PSS conductive elastomers, composite and the carbon-based polymer bends represent a new class of the functional material that combine the flexibility of the polymer with the electrical functionality of the metals and the semiconductors. Conductive polymers like the uh, mm, polyaniline, polypyrrole, and the polystyrene sulfonates are the special material that are the soft and the flexible like the plastic but can conduct electricity like the metals and the semiconductors. Unlike the conventional passive polymers, these materials participate in change the transport, ion exchange, and the electrochemical interaction. Means unlike normal plastics that do nothing electrically, these polymers can carry the electric charges, move ions, and take place in the electrochemical reactions. Next, the conductivity can be turned through the doping oxidation state, molecular alignment, processing method, and incorporation of the fillers such as the carbon nanotubes and the graphines. Um, Nanotubes and the graphene means the electrical conductivity of these polymers can be increased or adjusted by adding the chemical, changing their chemical state, arranging the molecule properly using the different fabrications method, or adding the material like the carbon monotubes and the graphene. Next, the electromechanical coupling ability allows them to function as artificial muscles and soft actuators. Means because of these material can convert electrical energy into the movement, they can work their artificial muscle or soft moving devices. When the stimulated electrically or the mechanically ion migrate within the polymer matrix, generate the volumetric expansion and the contraction. Means when the electricity and the chemicals are applied on move inside the polymer, causing it to swell, expand, or the shrink, contract. This leads to the measurable bending, displacement, or the strain, making these materials highly attractive in application where the lightweight, silent, flexible, and the low power actuation is required. This fine movement causes the polymers to bend or stretch, which is useful for the application that needs light, flexible devices that use very little power. Next, the objective of this assignment is to understand their structure, property, relationship through the experimental characteristic and the performance actuations. The aim of this assignment is to study how the structure of these polymers affect their properties and their performance by doing the experiment and the tests. Next is aims of study. The aims of this work is to synthesize or procure the conductive polymer films. Means the process of this study is to make or obtain the thin sheet of the conductive polymers, measure their electrical conductivity and change transport characteristics. Then their ability to conduct the electricity and move the electrical charges will be tested. Evaluate their actuations and strain response under the external stimuli. Means the movement, bending, and the stretching of these polymers will be checked when they are exposed to the external factor like electricity or the chemicals. Examine their morphology and the structural feature. Means their surface shape, structure, and the internal arrangement will be studied. And finally assess their lifetime cycling behavior and suitability for the actuator based application. How long they last, how will they perform after repeated use, and whether they are suitable for use in actuator devices will be evaluated. Next is objectives. To obtain the conductive are the smart polymer films either through the laboratory synthesis or the commercial procurements. Means to get the conductive polymer film either by making them in the lab or by buying them from the market. To measure the sheet resistance, resistivity, and the electrical conductivity using a 4-point probe method. Next, to study the frequency dependent impedance, charge transport, and the electrochemical behavior using the impedance spectroscopy. To study how the electricity and the ion moves inside the polymer at the different frequencies using the expenditure impedance spectroscopy. Next, to evaluate the actuation, response, strain, displacement, and the time-dependent movement using the optical measurements. Next, to analyze the microstructure defects and the film integrity through the SEM imaging. For example, to study the surface structure, pores, cracks, and the overall quality of the polymer film using an electron microscope. To perform the lifetime cycling test to study the degradation stability of the actuator response. And next is to interpret correlation between the morphology, conductivity, and the actuation efficiency, and they suggest the potential actuator applications. Next is the material and the sample preparation. Conductive polymer samples may include polymer aniline, polymer pyrrole, and the PSS films, conductive elastomers, bands. Graphenes, polymer composites are the commercially available conductive films. Means the conductive polymer sample used in the study can be material like polyaniline, polypyrrole, rubber-like conductive polymers, polymer fixed with the carbon monotube or graphenes are ready-made conductive films. Next, the important detail to record includes the film thickness, substrate type, processing or synthesizes routes, environmental conditioning, and the presence of the additive or the fillers. Means important information to note includes how thick the film is, what surface it is placed on, like the glass or the plastic, and how it was made, the condition it was kept in, dry or the treated with the chemicals or the water, and whether any extra material can be added. Next, in the film uniformly and the mechanical flexibility should also be noted, as their factors significantly influence both the conductivity and the actuation behavior. Means it is also important to check whether the film is smooth and evenly made and how flexible it is, because these properties affect how will it is conduct electricity and how will it move or bends. Next is experimental technique and methodology. 4-point probe conductivity measurements. The technique is used to accurately measure sheet resistance and the electrical conductivity while minimizing the contact resistance effect. Means this method is used to correctly measure how will the polymer conduct electricity while reduce the error caused by the poor electrical contact. And a controlled current is passed through the outer probe while the voltage drop is recorded between the inner probe. Means electricity is sent through the two outer probes and the voltage is measured using the two inner probes. Next, using the geometric correction factor and the resistivity and the conductivity are calculated. Means the mathematical formula are used to calculate the resistance and the conductivity for the measured value. Next, the measurement may be repeated at the multiple films locations to examine the uniformity and the thickness dependent effect. Means the test to done at different points on the film to check if the conductivity is the same anywhere and how thickness affects it. Next is impedance spectroscopy. Impedance spectroscopy provides insight into the electrical and the electrochemical transport mechanism within the polymer. Uh, Means the techniques helps us understand how the electricity and ion move inside the polymer. An AC signal is applied over a wide frequency range, and the complex in impedance response is recorded. Means an alternative electrical signals is applied at the and many different frequencies, and the polymer's response is measured. Next, from these response, the contribution of ionic mobility, electric conductivity, and the capability storage can be identified. Identified means these results show how much of the current comes from the ion movement, electron flow, and the energy storage inside the polymer. Next is the optical stain and the actuation measurement. The polymer strip is mounted as the cantilever or the freestanding actuator. This polymer is fixed at the one end and the left free, so it can move and bend like an actuator. External stimulus such as electrical potential, humidity, temperature, or the electrolyte exposure is applied stepwise. Different external conditions like the voltage, moisture, heat, and the chemical are applied gradually. Means it, next is a displacement, bending, curvature, strain, percentage, response time, and the recovery behavior are recorded using the optical tracking or the video analysis tool. Means the amount of the bending, stretching, speed of the movement, and the how will it return to its original shape are recorded using the camera or the optical tools. Next is strain versus the stimulus, and the strain versus the time curve are generated to quantify the actuation frequency efficiency. Means graphs are made to show how the movement changes with whether the stimulus and the time happening to measure how efficient the actuator is. Next is the scanning electron microscope. Scanning electron microscope imaging how the investigation of the microstructural morphology including the fibril alignment, uh, grain domains, track, interfacial bonding, and the surface roughness. Means scanning electron microscope is used to closely examine the structure and internal structure of the polymer, such as the fiber, pores, cracks, and the roughness. Next, the structural factor. Structure factors strongly affect the charge transport, ion diffusion, and the mechanical reliability of the actuator behavior. Means the surface are a structural feature directly affect how will the electricity and the ions move and how strong and reliable the actuator is. Next is a data analysis and the required plots. The assignment requires the generation of the following key steps and the plots. Mm, the conductivity versus the film thickness and the doping condition. Means a graph should be made to show how the electrical conductivity change when the film thickness or the doping level change. Next is a displacement and the strain versus the applied stimulus, voltage, humidity, temperature, etc. Means a graph should show how much the polymer bends or stretches when the different external conditions like the voltage or the humidity are applied. Next, the strain versus time plot showing the response and the recovery dynamics. Means a graph should be made to show how fast the polymer moves and how quickly it returns to its original shape over the time. Next, actuation amplified versus the cycle number to evaluate the lifetime and the fatigue. A graph should show how the movement strength changed after repeated use to check the durability and the fatigue. Next is the optical conductivity degradation versus the cycling results. Means an optical graph can show whether the electrical conductivity decrease after many cycles. The results should be critically analyzed to understand how conductivity influences actuation strength, whether the material behavior like a resistor, a capacitor network, and the whether actuation exhibit the hysteresis and the lags. The results should be carefully studied to see how the conductivity affect movement, whether the material acts like the resistor capacitor system. Next, many reduction in the performance during the cycling should be linked to the possible cracking, delamination, oxidation, and the water loss related degradation. Means if the performance becomes worse for after repeated use, it should be explained by the problem like the cracks, layer separation, chemical damage, or the loss of the moisture. Next is discussion and interpretation. The interpretation section should correlate morphology, electrical transport, and the actuation characteristic. This session should explain how the structure of the polymer, its electrical behavior, and its movement performance are related to each other. For example, dense film may show higher conductivity but low swelling induce actuation, while the porous films may exhibit the strong actuation but the weaker mechanical durability. Means, for example, compact and dense films usually conduct electricity well but do not swell and move much, while the porous films can move more but may be weaker and the less durable. Next, impedance behavior may reveals whether the polymer conduction is dominated by the ions or the electron. Means the impedance results helps identify whether the electricity flow mainly through moving the ions or through the electrons. SCN observation should be linked to failure modes or performance loss during the repeated cycling, where the possible results should be compared with the values reported in the scientific literature to assess the relative performance. Next is suggestion actuator application. Based on the measured strain capability, response time, reversibility, electrical efficiency, and the cycling stability, suitable application domains should be processed. Means the suitable use of the polymer actuators should be suggested based on how much they move and how faster they respond. How will they return to their original shape and how efficiently they use electricity and how stable they are after the repeated use. Next, these are induced soft robotic actuator, artificial muscle, flexible grippers, wearable motion assists system, biomedical micro actuators. Micro valves are the fluidic control and the adaptive and the smart surface structure. Justification must be supported by the quantitative results rather than the general statement. And next is conclusion and the future scope. The assignment should be concluded by the summarizing the key finding connecting electrical conductivity, impedance behavior, actuation performance, and the material morphology. Limitations such as a slow response time, limit strain, and the cycling degradation should be acknowledged. Future improvement may include the optimization or dropping level, multi-layer structure, incorporation of the mono or fillers are the encapsulation strategies to enhance the durability and the environmental stability. Thank you.